Good morning, everyone. Those of you joining in. Morning, folks. Just letting everyone filter into the room here. We'll be quiet for a minute or two while we get all the participants here active in the webinar. Hope everyone's having an amazing day wherever you are in the world. And good morning again or good morning, good afternoon, evening, wherever you are in the world. For those of you just joining now, I happen to be on the West Coast in the United States, so it is morning for me. We are just waiting a minute for the room to filter in. All right, I think we have a pretty steady list of people here coming in. I think we can probably get started here in just one more minute. Looks like we've pretty well stabilized, so I think we'll go ahead and get started. So welcome to our monthly webinar here with myself, Tim Shryack, and Jeremy White. This is our seminar focusing on the key to clean data for network automation. Enforce and codify your organization's business logic with Nautobot's data validation engine. Little agenda that we have here for today. We're going to go through the intros, of course, current state of network data management. Standards are more than just templates, introduction to data validation in Nautobot, treating standards as codes, and of course, Q&A. Throughout the Q&A section, we will address those towards the end, but please do to put your questions in as the seminar is going on. Happy to address them as we can throughout the session, and then if there's time left at the end, we will address some as well. For those of you that maybe attend our some webinars regularly, you probably know us. Myself, Tim Shryack, and Jeremy White. I am the Director of Sales Engineering, and Jeremy is our Principal Developer Advocate. Great to see you all again, and welcome to those that maybe haven't been here before. As always, we'd like to let you know about our upcoming Nautobot workshops and other public trainings we have available. We do have a series coming up that's really amazing. Some incredible sessions, Source of Truth and Nautobot Fundamentals in July. Nautobot Extensibility Workshop, which I think is really cool. That's going to be a really deep dive into how you can use Nautobot to really custom your environment in August. Automating Nautobot with Python and Ansible, again in August, and then creating Nautobot apps course in September. So heavy focus on the Nautobot world as you look at the upcoming trainings available there. And for those of you here in the webinar today, we do have a really cool discount for you as well. If you use that code NAUTO10, you get 10% off. You will see that link here in the chat session as well. We'll have that drop there for you. And now I'll hand off to Jeremy.
All right, welcome everyone. So as Tim has amazingly set me up, we are going to be talking about the data validation and network management of our data and how we are able to best utilize and best steward the data that we are using to be able to automate our networks. Some of the key concepts that we really need to keep in mind, especially as we're moving into an automated world, is that good data in equals good automation out. Whereas if we have bad data in, we could potentially have bad automation that flies out at the speed of light to our networking devices. So let's first kind of dive into where we are currently within our data management portion within our infrastructure. So before we even get into the automation realm, let's first kind of talk about standardization and what are our industry standards, what is our business standards, what is our potentially regional or location-based standards, because every organization is going to have standards, and these are going to fall into a couple different categories. For instance, we're going to have certain levels of hardware standards. We may have certain devices that only this PID can perform this specific type of role within our network. We potentially may have a set of MX480s that are only allowed to be able to perform as core switches, or as an edge device, where then we have our 3850s and our 9300s that are only able to perform as access layer. And that is a business logic that is enforced upon our standards, not necessarily something that is required of those devices. Because as we've evolved our networks, the dividing line on some of the roles that some of these devices can play has gotten a lot more blurry. So as we start evolving, so we see we have our base hardware standards and what we allow to function as certain roles. We also then start influencing how we name different parts of our devices. And it could be the host name, it could be VLAN names, it could be ACL names. So we will commonly see within a lot of organizations that a best practice we might use is using the IATA airport code plus a role. And so in the example that we have on the right, we'll see that our WAN device for the DC metro area, which I'm located in, is going to be IATA1, WAN 01. And then our access devices are going to be IATA1, Access 01, and Access 02. And we can start seeing that based off of our standards and based off of how we are architecting and deploying our network, that adhering to the standards is going to make our life a lot easier from a network operations perspective and from a troubleshooting perspective. And then we also have what's going to be our design standards. And so these are going to be certain things that are maybe potentially non-functional requirements. This could be how we cable things together. This could be something to where maybe we're doing spine leaf or a 3-tier design, or if we're doing a collapse, or whatever we might be doing. These can be our actual design standards that are even a little bit more difficult to codify and a little bit more difficult to enforce from that perspective. And the biggest crutch of this whole entire situation or this whole entire paradigm is going to be the interpretation of said standards and how we potentially describe and write up and document our standards and how they're interpreted by the next engineer that comes in behind us, and how we have that human element and how that human element can and not necessarily be the most cohesive when it comes to enforcing said standards. And as we talk about this, we can say one thing very clearly, that what's clear to me may not necessarily be clear to everybody else. As an example, on this slide that we see here, we can talk about the use of our IATA airport codes and using that as the prepended portion of our device host name. Now, if you've been to any major metropolitan area, you'll quickly know that each metro typically has more than one airport. Within the Washington, DC metro, we have Reagan and we have Dulles. So we have DCA and IAD or IAD. And so very quickly, we could see that if I see IATA airport codes, I could use DCA or IAD, and kind of understanding that, yes, it might be clear that we want to use the major metropolitan airport for that specific location, or potentially the overarching city code from IATA, but it may not be as direct and clear. So if we also include the IATA city code, we also have WAS for the Washington, DC metro. So unless this is clearly codified and spelled out, we could potentially have IAD, DCA, and WAS as just our site name that's part of our host name. And then the last thing to always keep in mind is that our networks are constantly evolving. Whenever I first got into networking, it was most common to see, and this was still kind of a practice that was taught by Cisco and the CCNA, was their 3-tier network design. And especially looking at that within our data centers, our user access, and whatever it might be. But now we're seeing an evolution into a spine leaf architecture and using layer 2 overlays like a EVPN VXLAN solution for layer 2 span instead of a traditional layer 2 span with a common core router. So as we look at this and as we understand and realize that we all have different standards and we all have standards that we have documented and are trying to assert what said standard is, we're always going to find an XKCD, of course, that is going to fit our exact situation. How are standards proliferated? We've got 14 competing standards. Oh my goodness, this is just absolutely ridiculous. We need to have a new standard that covers everyone's use cases. And now we have our 15th standard, and they're all kind of coalescing and they're all kind of fighting each other to be what is the dominant standard and what is the expectation. And as we look at what happens in our evolution of our networks and when it comes to standards, as we introduce new standards or as we potentially have different standards for different potential pockets, unless we have some overarching way to enforce that standard or some way to audit against what is currently deployed versus what our current standard is, it becomes very difficult to continue to try and to charge towards a single collapse standard. And then back to my IAD versus DCA example, we can very quickly see that if I was intending it to be the major airport in the metropolitan area, that is the IATA code, not the regional airport that is in that metropolitan area. And we can kind of see that in this specific example. Is this going to break anything? Absolutely not. But is this something that is going to potentially cause design drift, or that we're not exactly 100% within our design standards? Absolutely. And then we also look at how things happen as networks evolve and as we introduce new changes, and how we have our original site of having a WAN device with 2 access layer devices and having an MX480 and a 3850 and a 9300, whereas our V2 design is going to be a ASR 1001 with a stack of 9300s, and how we can evolve what our current standards are to what our next set of standards are, and potentially have different standards that can be applied to different regions or different portions of our network. So one of the major things that we also need to keep in mind is that even though we have our standards, and our standards do influence different items within our network design and our network configuration, our standards are more than just what our templates are. And so we can very quickly see that we have certain things when it comes to our design standards that are influencing our templates. So our model, our vendor, our location can be directly influential against our configuration and how we are building and structuring our templates. But that's not necessarily always going to be the sole driver, the sole case. So in this example, we can see that we have our syntax generation, which is what is driving what our templates are. And then we have our data generation, which is going to be driving what is the inputs into that template. And then as we can see, we can very quickly and easily translate this into what our actual inputs are. So a more realistic example of here's our YAML definition of what that interface definition may look like, and how we can iterate through that inside of our template and potentially have different types of designs or different types of decision making based off our templates. This is a very simplistic example where we are essentially just templating out our interface configuration, where we have our normal access layer here, and then we have our interfaces that are a type of trunk being dispatched to a separate template. But kind of understanding that standards drive templates and that they're not always going to be a same for same or have the ability to use configuration to directly define and understand if we are compliant or if we are correctly within our design. And this is absolutely going to be pertinent when it comes to what our data looks like and what is our data model, what is our ingestion method. And always kind of back to that same exact example of DCA versus IAD, and kind of understanding and looking at what our current paradigm is typically within networking and how we are able to potentially use automation to help enrich how we're able to manage our networks. And so in the example that we have here, I've got 2 separate sets of inputs. I've got my IAD 01, WAN 01, and I've got DCA 1, WAN 1. And we can say that based off of our template, our site, role, and index are concatenated together to form our host name. And so we can quickly see that although we have the appropriate attributes to build out our template and to template out our host name, we potentially have an incorrect host name that gets pushed all the way to the remote device. So in this paradigm, and what I've seen historically within networking, is our enforcement is done after the deployment's already happened. So what we do is we enforce all the way to the far right-hand side to where we're enforcing what is the actual configuration or the actual state of the network. And we're not enforcing on what we're putting in as valid inputs. In this paradigm, we only catch this non-standard item once it's actually on the device. We don't catch it when it's in the input section, which could be in a set of host vars and group vars inside of Ansible, or inside of a config context, or actually a device attribute inside of Nautobot. So we can see this is more of a reactionary approach of being able to validate and understand if our data is valid and is it exactly per design. Now, what we want to do actually is we want to flip that paradigm. We want to ensure that we can enforce our standards on our inputs and not on the outputs and what's actually been deployed to the device. And so by trying to push this business logic to validation of our inputs and validation of our templates on the ingress side, not on the egress side, is going to give us the ability to ensure that we never deploy non-standard configurations or non-standard items. And we are able to enforce the health and the likelihood of our data being able to be more repeatable, and it's going to be able to align better with our templates and our design. Now, with this example, I'm going to be perfectly honest. Is hostname going to be something that is going to be the most critical thing in the world that could potentially break all of your automation from your inputs being incorrect? No, absolutely not. Not going to be the case, but there are scenarios where you can enforce levels of business logic on dependent items to have a better understanding, a better discernment of what that good quality data, that valid input is going to be. And that is where we can start looking at potentially, we could look at how we're looking at our BGP configuration based off of cables and interface roles, and kind of being able to discern that we have a direct connection across two separate backbone routers that are peering with BGP. Based off of the interface role and the cable that's associated, I know what my remote end peer should be. I know what my remote end item is. And if I try and define that information inside of my configuration context or inside of my BGP model, I can firmly assert that that's not valid. That's not going to check out. And I can enforce that standard at the beginning where I'm trying to ingest my data and prevent me from potentially pushing out bad configuration to my network. So I've talked about why we should care about our data on the ingress side and why it's pertinent to be able to try and enforce our data quality earlier on versus being reactionary on our networking devices. So let's get into data validation inside of Nautobot. And with that, our first major thing that we will be talking about today is going to be the data validation engine, which is a Nautobot app that is directly geared toward enforcing a set of rules against the data housed inside of Nautobot. So although Nautobot is absolutely built around a relational database, and we have the ability from the database perspective, as we're defining our models, to define certain rules or certain validations, but that's always going to be defined at a more generic industry level. It is not necessarily going to have directly what your specific business logic may be, what your design logic may be, and what that human element is for your organization. And so that's when we start looking at introducing things like min-max rules within data validation engine, regex parsing, so we can enforce a level of standard on fields with regex. Maybe we have a specific field that by default inside of Nautobot, it's a non-required field, but per our design and our standards, we want to enforce that field. An example of that could be within a device, a DSIM device, we potentially may want to enforce that we always have an asset tag. Maybe that is our standards, that is a non-functional requirement. It's not going to impact our network operations. It's not going to impact packets flowing on the network itself. It's there for audit tracking and asset tracking. And so we want to enforce that every single device in Nautobot always has an asset tag. But it's not enforced by default. So we can use data validation engine to now mark that specific field as a required field. And maybe we also want to enforce a level of uniqueness on specific fields. So again, back to the concept of Nautobot and the data models that are built are meant to be a generic industry standard that can be able to fit multiple different use cases and are not going to be very specific and very targeted to potentially your business logic or to your design logic. And so for an example of this, our device names within Nautobot, our uniqueness value is not based off of the name attribute. It's a uniqueness based off of a couple different attributes combined together. But maybe we want to enforce a uniqueness value solely on the host name. So we can enforce that we do not have any duplicate hosts with the same host name inside of our Nautobot inventory. And the way that this looks like within the Nautobot UI for data validation engine is that we can apply these specific exact use cases to a min-max rule. So we have our min-max rule, and our example here is, let's say we are purposefully reserving any VLAN that is over 4,000 or greater for later use. May have been a decision that was made eons ago, and we're not sure why, but there's a design standard for a very specific reason that we want to enforce all VLANs are less than 4,000. That's not a native validation as part of the VLAN ID on the VLAN object inside of Nautobot. And by leveraging data validation engine with min-max rules, we're able to apply our custom business logic and our design logic onto any model and any field on the model inside of Nautobot. So in the example that we can see here, we have a min-max rule that is applied to the IPAM VLAN content type with the field of VID, which is the VLAN ID. And we're not necessarily having to specify the minimum number for our VLAN ID because that's going to be inherently covered by the model, but we are going to be enforcing our maximum VLAN ID of 3999. And so little small things like this, which seem very minimal and seem very insignificant on the surface, enforcing these levels of standards directly on the database itself is something that can very much improve the data quality and the long-term data integrity as we're looking at rolling out automation at scale and how that is impacting how we're able to manage our networks within a modern data-driven environment. We also, as I mentioned, we do have regex rules. So this gives us the ability that if we can define if we can define the regex, we can absolutely enforce that regex pattern on a given attribute. So as we go back to our previous example, we want to use our airport IATA airport code with the 2 digits, device role, and then device index. And so we could very quickly see that we're able to easily write a set of regex that we can then apply and enforce that standard on a device name field. And so we can very quickly see that this is something that we can start getting closer to enforcing those standards and starting to enforce a set of naming standards when it comes to our devices. And again, about our required rules, and our example use case here is that we do want to make sure that every single device has the asset tag filled out, where that we have that asset tag, we have that level of tracking no matter what. And that's by default a field that is able to be blank / nullable, whereas we want to enforce that to actually be a set field no matter what. And we want to apply that to all devices within Nautobot. And then lastly, of course, is going to be our uniqueness constraints, which we have the ability potentially, as I mentioned, if we want to enforce a unique device name inside of Nautobot universally. So not as part of a concatenation of multiple fields, but universally device name has to always be unique. And that's not a native behavior Nautobot. We can use data validation engine with the unique validation rules to be able to enforce that level of standard. Now, let's jump over to what this looks like inside of Nautobot directly. So
Jeremy,
if we
while
go
you're
in,
prepping for that demo there, we just had a quick question I thought I would ask because I think it's
sure.
pertinent here. Can the data validation engine enforce rules on objects based on specific attributes? For example, apply a regex rule to a host name on all devices with role access.
So that is going to be pertinent to the actual information that is in the actual regular expression. So if we come in here and we take a look at this, Absolutely. So this regular expression that we are applying is going to be a Jinja2 template. So we could potentially apply Jinja2 templating to build out our regular expression. And so if you want to do a regex demo, we're going to put this to content type dsym device. I'm going to say this is going to go to the name field, and we can do object.site.slug. We'll say a digit plus dash object device role slug. And then we can do digit plus. And this should be able to give us the ability to be able to enforce based off of this specific item. So we're not necessarily writing a generic regex match here. We are actually firmly asserting that so let me just do a new line and kind of showcase what this could look like differently. So we could potentially do 3 digit plus dash. I think that's essentially just going to be a copy passive of that there. So essentially, if we wanted to have a more generic regex parsing rule that is built, we could have it to where we're not necessarily caring about what the site ID is. We're not necessarily caring about what the device role slug is, but we're just caring that it's matching this specific pattern. Whereas if we're wanting to use the actual site that is associated with the device and the actual device role that's associated to the device, we can absolutely do so. So if we create this, now we should be able to go over to our devices. And if we wanted to grab a random device, and remembering we have our site digit plus, so at least one to n digits dash roll slug, and then 1 to n digits. And we edit our item, and we do let's do a 1 there. That I believe should invalidate our item. And we hit update, and we'll see that it's not going to be conforming to our actual regex value. So we can see by absolutely using Jinja2 templating with the regex parser that we can say that it is expecting to be AMS01 to a digit. So technically, because of the if I go, I'll need to go back and update that because 01 is part of the site ID, which is perfectly fine. But we can see that in action. So let me do this in another window. Grab that. We'll edit it, and we can very quickly see that, oh, crud. The digit portion of the site is actually going to be coming directly from the site ID, so we don't have to worry about that. Now I can hit update. And now, in theory, if I remove that number there, I believe we should be good to go. I can click update, and oh, my goodness, I don't have an asset tag. So I'm going to do asset tag 1, 2, 3, 4, 5, 6. And then now I hit update. Oh my goodness, I don't have a unique value here. So we can kind of quickly see how these types of items can really enforce us from being a bad actor by mistake and be able to enforce a level of sanity within our networking devices.
I think that's great. And Anthony, hopefully you can see the power of the capability to have the Jinja templating in there really gives you that flexibility to enforce the rules however you wish. So, yeah, amazing, Jeremy. And thanks for the on-the-fly live demo. Great.
Absolutely. And we can quickly see that how it cascades out. And so we can see if I jump back over to AMS01 and I just pick another random device, I'm going to see that I don't necessarily have an asset tag that is set on this device. So I created the validation rule after I created the device. But now if I was to come in and potentially want to edit anything on this device and hit update, it's automatically going to start yelling at me saying, hey, I can't update this because you've not met the minimum requirement of having your asset tag set. So now I can do, this is 4, 5, 6, 7, 8, 9, and then click update. And now I'm able to, if I don't know, there we go. Enforce my standards, there we go. And then now we're off to the races and everything that's going to be unique, everything that's going to be enforcing what our level of standards are when it comes to min-max rules, when it comes to regex parsing, requiring certain fields, and a uniqueness constraint within our deployment. So far what we've done is we've talked about what is the current state, how are we able to manage and use the actual data that we have to enforce a data-driven approach on network automation. How can we make sure that we're having good, clean data in so we have good, clean automation going out? And we've looked through how we can be able to leverage the min-max, regex, unique, and required rules within data validation engine to enforce a level of standards on our automation and on our data itself. But if we're treating our infrastructure as code, and we've codified what that data model looks like and how we're being able to build and design our networks, we should also be treating our standards as code, so our design standards. And yes, absolutely, you could enforce the state of those validations through a Nautobot job or through an API calls where you can codify those and use those as the actual JSON payload and be able to enforce those standards in that manner. But what happens if there's additional custom business logic that is not going to have a direct home inside of those 4 rules? Or let's say we understand and we know that we're in a brownfield scenario. And as we saw on the previous example, whenever I was editing, if one of these rules did not pass, I couldn't save the device. I couldn't update the information. So what happens when we're in a scenario where we have data that we want to enforce for anything net new? We have data that's already in there that is not necessarily the greatest quality of data. How do we want to enforce this information? And how do we want to make sure that everything is healthy and is good to go? But we don't necessarily want to prevent people from making changes. And that's where we can start looking at treating our standards as code and how we can potentially start auditing and be able to run levels of reporting to understand when things are non-compliant. So we're back to data validation engine, and a new feature that's being developed for data validation is going to be audit rules. And audit rules are going to give us the ability to publish these rule sets via a Nautobot app or a Git repository. So if you are someone who is fairly well along in your automation journey and you're fairly well skilled at being able to build, publish, and manage custom Nautobot apps, you can absolutely take the same approach. Or let's say you want something a little bit more lightweight. Let's say your Nautobot instance doesn't have any custom apps developed in it. We are just using what are the out-of-the-box core apps and some network to code maintained apps like Data Validation Engine or Golden Config. We can then write our rules and store them in a Git repository to where that we can continually enrich our environment and make changes without having to do a full redeployment or do a full upgrade. Within audit rules, we do have the capability of initially just doing reporting. So as I had talked about, and as we had seen just a moment ago, whenever I try to make those changes and I introduce a new rule that was not already enforced, I can't make any changes to that device until I'm in compliance with that new rule that I created. So maybe I want to create a set of rules that are initially just reporting only, instead of having to be enforcing from day one. And one thing to also keep in mind is that the default behavior for any of the custom validators or audit rules or validation rules within Data Validation Engine, there's going to be one thing that is going to be a common theme around them, is as we're implementing our automation, as we're managing our Nautobot instance, as we're managing our potential Nautobot jobs, the default behavior is this is directly tied to being able to perform a clean method on the actual model itself. And so by default, anything that is a UI form that is a traditional Django form is always going to call the clean method. Any API call is always going to call the clean method. But as we look at things within Nautobot jobs and we're working directly with the ORM, do always keep in mind that we do want to make sure that we're using the validated save method to ensure that we're able to still enforce those level of validations and attributes on our object stored inside a Nautobot. And then as we're moving on in our journey, we've created our validation rules, we have our custom business logic, we're able to assert what we expect to see. We can then flip the scenario from a report only to a strictly enforce. So we can then be in the paradigm of that first scenario where I introduce a new rule and I can't save the device until I'm compliant. We can have that same type of paradigm with audit validation rules. So we're brownfield, we have attributes, we have devices, we have models that are non-compliant, and we don't want to prevent people from being able to make updates. We want to be able to audit to see what is non-compliant so we can work towards updating that data in an appropriate manner. And then once all that data is up to date and everything is compliant, we can then turn on an enforcement onto that rule so that we can ensure that any net new data that's coming in is not going to be invalid and that no one is able to edit existing devices and make it invalid. And the biggest thing around audit rules when we look at it in comparison to the min-max, regex, required, and unique rules is that there's going to be some times that we have custom business logic. We may have non-functional requirements. We may have something within our design parameters that influences what our data should look like that we can't directly accommodate with a regex pattern or a maximum value. So we then need to pull it into Python and implement what our custom business logic might be. This could be filtering based off of region and role, and that gives us an additional subset of roles that are only specific to that region and role. And as we can see here on our example is that we have essentially the same exact regex parsing that we did a second ago inside of the UI, but we've now turned this into an audit rule. And we have the ability to basically go through and see exactly what is going to be compliant and non-compliant when it comes to our device host names. If we take a step back and we look at it from the standpoint of, yes, I can do a regex rule. How do I know that anything that is currently in our Nautobot instance is matching that regex rule? It's not a direct feature of the regex rules, but in an audit rule set, I can implement whatever my business logic might be. And even though this business logic is matching the same regex rule logic that we had just implemented, I can have the ability to have that reporting capability. And so we can see at the bottom that we have a new tab that shows up underneath our devices or whatever content type that we're associating it to. So we can see that we're associating this one to a decent.device. And we have the ability to be able to see exactly which specific attribute has been validated. Is it valid or is it not valid? Is there something that's specifically missing? Can we potentially daisy chain multiple validation errors together? And what might be happening there? And this is something that can be very powerful, especially as we're in the paradigm of wanting to shift from brownfield to greenfield and be able to understand what is non-compliant in our data and how can we move towards making it compliant to where we can have that more repeatable item and have a better semblance of how we're going to be building and managing our networks at scale. So some benefits of managing our standards as code. So as we're going through and as we're looking at implementing our custom business logic inside of our audit rules and how we can then use that to publish into our Nautobot ecosystem, either through a Git repository or through an app, we have the ability of enforcing these standards and having additional sets of oversight upon those standards that are being implemented. One of the biggest things around that is the GitOps scenario, being able to use branching and merging strategies to be able to have other sets of eyes to be able to enforce that level of standard. And because we are constantly evolving, constantly updating what our standard definitions might be and when they may be changing, when they're going into enforcement, we have the ability just natively within Git log to be able to see the who, what, when, why on our changes to be able to see exactly what specific line in code changed from whatever the previous commit hash was. And we can see the commit message, which hopefully people are unlike myself and have more meaningful commit messages, but you hopefully can be able to see exactly what was happening, what was being brought in as part of that change, what other changes happened at that exact commit hash, and when was it introduced. And the biggest thing here, as we circle back to the beginning of the webinar and what we were talking about when it comes through our designs and how we're defining our designs and how we are publishing the documentation, is that there's a tremendous amount that is left for interpretation. And the more that we can push the bad guy to the machine and let the machine be the one that says, nope, you are not compliant, or yes, you are compliant, it kind of removes that human element. It kind of removes the potential for interpretation so that we have something else that is enforcing what our set of standards are, instead of having me interpreting what I think our standards are and how that applies to the network deployment that I'm building. So there's a few other items outside of data validation engine that we can use to enforce a level of standards and a level of design within our networks. We absolutely have the ability to leverage Nautobot jobs to be able to do our traditional legacy reporting. So we can perform, we can do an ORM call, grab all of our devices, and then we can look at every single device for a specific attribute and see if that specific attribute matches what we care about. And we can absolutely still implement our custom logic inside of Nautobot jobs to have our custom business logic to enforce that set of standards. We also still have the ability to perform Nautobot app validators. So these are going to be very similar to the audit rule sets. The biggest difference between audit rule sets and app validators is going to be the audit rule set can be just report only, whereas our custom app validators are going to be strictly enforced no matter what. So similar to our min-max regex requiring unique rules. And lastly, we do also have the ability to be able to define our config context schema. That's an interesting one there. So we've been talking up until this point solely about enforcing levels of logic on a relational database and specific fields inside of a relational database. And we've not talked as much about enforcing validation and data integrity upon essentially a JSON payload. Could be YAML, could be JSON, just whatever our structured data is, as essentially a document store. And this is where we introduce JSON schema as a config context schema language to be able to build and define what our config context should look like and how we can enforce a level of standards on our config context so we can block bad data coming in via a config context. I'll be the first to admit, I absolutely love the flexibility and the ease of use that we get with config context, especially not having to adhere to very strict relational database standards. But also it scares the bejeebus out of me, understanding and knowing that I see Tim has come back on video, so I'm just going to pick on Tim for a second. I've built this amazing automation workflow that just solves world hunger and does everything. And then Tim comes in and sticks in a new key value pair, or maybe he stringifies a Boolean value. That all of a sudden breaks absolutely everything because I didn't have any type of scenarios to catch those exceptions or account for those examples or those use cases. And I don't have a schema definition to enforce my standards on that document or on that JSON payload. So Tim, trying to be a helpful person, trying to help me with my change, accidentally stringified a Boolean value, and now it's broken absolutely everything. And by enforcing these standards with a JSON schema inside of our config context, we can prevent those things from happening. So we could potentially say, in this example here, group is active as Boolean. Now it's not going to allow a stringified Boolean value. It has to be a true Boolean value. So before we jump into thank you, let's also take a look at some audit rule set. So as we can see here, we have our simple audit rule set that was created that I've already loaded into my Nautobot instance. And this is just a very, very simple, essentially one file repo. I don't have to worry about creating a full Python package or publishing it to a PyPI or anything from that effect. I have the ability of saying that based off of whatever my custom business logic is, I can update this information, push it into Nautobot, and then be able to enforce that level of standard. So if we wanted to, let's say, if instance dot site dot name to slug equal AMS 01 and not regex match. So basically what I have changed here is I initially just had my regex matching for my site slug device role and device index. So now saying I'm only wanting to enforce this just on AMS 01. And this is a very simplistic example, not something that is truly insane or great or anything major, but it gives us the ability to say, we're only enforcing this here and we're implementing what our custom business logic is. And we can see that I'm making decisions based off of ORM calls, based off of related items, related objects inside of Nautobot. And I'm able to make decisions based off of that pattern to be able to enforce certain standards. And all I would essentially have to do, save, git add all, git commits -m, only enforce on AMS 01, git push origin main. And very quickly and easily, we can see that I can then jump back over to my Nautobot instance. I can go to extensibility, git repositories, and I can update my rules and I can automatically pull this in. And now this updated pattern is now being enforced only on AMS 01. And it gives me the ability for that I can go in and I can see based off of running the specific job, which devices are compliant, which devices are non-compliant. So if I just quickly went over to jobs and I ran my run registered audit rules, because I've just introduced this new change to my audit rule sets, and I run my job, select my specific audit rule set, and I click run. As long as the demo gods smile upon me, we should see this complete in a fairly short period of time. Nothing too terribly crazy. There we go. And now I can go into extensibility and go into audit rule sets. And then now, in theory, the only devices that are going to be non-compliant for this specific audit rule set are only going to be our AMS devices. So if I filter to valid equals no and apply, I'm not expecting to see anything that is outside of AMS 01. So let's just go take a look here. Foobar, yep, Foobar is absolutely in the AMS 01 site. Now, if I was to edit this, I am going to need to add an asset tag there. I'm going to say, oh, crud, I put this in AMS 01. I actually meant to put this in, if I could type, United States. I'm going to put this in IAD. WS, swing and a miss. IH, and put this in ATL. I am batting 1,000 here.
I'm enjoying watching the rules do their work.
Yes, then we can very quickly see that, oh crap, we also still have the original regex validation rule. So if I come in over here, I go back to my regex validation rule. I'm just going to go ahead and delete that because we now have this codified as part of a rule set. We natively have that enforced directly inside of Nautobot. So I've now fixed my two issues and I hit update and now we should be good. And if I look at my audit rules, we'll see that everything is valid. So as soon as I save it, it does rerun the audit validations against that given object, and I'm able to get the immediate output. And if I rerun the exact same job, Foobar 1 is not going to be non-compliant anymore. Foobar 1 is going to be compliant because it's no longer the AMS 01 site. And so we're not enforcing that standard that I applied to just the AMS 01 site. And we can see very quickly that by building these items through a Git repository and being able to leverage tools within the GitOps paradigm of branching and merging strategy, and being able to have me potentially create this as a branch and submit a merge request and tag Tim to review it. And Tim can say, what the heck, man, why are we only enforcing this on AMS01? This is a simple item that should be everywhere. Enforce it everywhere. Why are you limiting it? And that can give that level of having controls, having the ability to have approvals, and going through the same type of change management process when it comes to enforcing our standards on our network and how we're building and managing our infrastructure and our data that is driving our network automation. With that, it looks like I've saved about 10 minutes for any
Excellent.
questions. And do we have anyone that has any questions?
Right now we don't have any outstanding questions at the moment. I just had a comment. I loved the slide that you had that said codify and let the machine be the bad guy, because I think that really expresses the notion that as we move into operating our networks and our environments through code and using DevOps principles, it highlights the idea that we really need to very clearly articulate and express our standards in a way that is unambiguous. Because traditionally it is very ambiguous, and we do that traditionally because we leave it up to the engineer to correctly interpret. And that's fine if we have a senior level individual that's been at the organization for 10 years and they have a map of the environment in their head, they understand. But you hire somebody new, or maybe you bring on a junior individual, they don't understand. And if the standards are not clearly articulated, it's very difficult for them to learn and understand how they should operate the environment correctly. And I think that's one of the major advantages of infrastructure as code in general, is that it forces us to be unambiguous, that we have clearly defining what we expect to happen, both from a standards perspective and from even our network intent perspective. So I think that's a great paradigm shift for us to think about as network operators. And we do have, sorry, Jeremy, I was just going to say to the audience here, we do have a couple minutes. If you've got any questions, please do fire them into the channel. I think this is an amazing view of what and the power of Nautobot, honestly, and that ability to layer on these components on top of the database.
Absolutely. And just adding to your point around letting the machine be the one that's enforcing, letting the machine be the bad guy. This XKCD has like perfectly described almost every organization that I've been in that has potentially acquired other companies along the way, or has had a constant evolution in their networks. And no one has ever gone back and reinforced and gone back and changed to make sure things are updated to the current standard. Because we never had a reason to. We never had something that was auditing us and forcing us to be in compliance and be in standard. And this is something that would always drive me absolutely bonkers, going from, let's say, a legacy Houston data center to the Dallas data center to Washington, and seeing massively different naming standards, massively different use of VLAN IDs, and different things that were these tiny bits of metadata that help describe and help us troubleshoot our networking devices and help to understand what should be happening. And it was always so vastly different depending on when that specific pod in that data center was deployed and who did the deployment. You could absolutely see the difference between who deployed from pod A to pod B to pod C, and how
which
that
version
impacted.
of the standard did we use, right? Or even which subversion of the standard did we use? Yeah, absolutely.
Absolutely. And maybe we have something buried at the top of the standard doc that says everything that's user defined is supposed to be all caps. And we don't call that out later in like host name or VLAN name or access list name. And then we're using all lowercase. We use all caps to make it anything that's user defined. It makes it immediately apparent to you that it's a user defined, user configurable name. But we only call it out in one spot. We don't call it out everywhere. So we miss it all the time. We then have VLANs that are named with a lowercase instead of an uppercase, and which is a minor, tiny thing, but it's always, it comes down to that standardization, that repeatability, and how that impacts operations and triage and troubleshooting.
We do have a question, Jeremy. The audit function is available with which Nautobot versions?
So the audit function, this is in a current pre-release of the data validation engine, and is going to be part of the data validation engine plugin. It's not a direct native capability of Nautobot. Similarly, if we come back over to my demo that I have open, all of these rules are published as part of data validation engine and are not direct native capabilities of Nautobot. The direct capabilities from a data enforcement perspective inside of Nautobot is going to be our config context schemas, which is defining what our JSON schema representation would be of our config contexts, and the ability to publish custom validators using a Nautobot plugin that has been developed.
Highlighting the power of the Nautobot app ecosystem. That is really why we created the app ecosystem, because it allows us to layer on these additional functionalities on top of the Nautobot core. And you can pick and choose, right? Like maybe you're not ready for this in your environment. Totally fine, right? You can bring it in at a point where it's good for you. So that gives you that flexibility. Again, highlighting that notion, I think even Jeremy was talking about another thing I loved was when you mentioned about, hey, we don't have to always enforce. Maybe we initially, we've got a brownfield environment. We're trying to ingest devices that aren't going to meet our standard. We need to get them into the database, get them cleaned up before we can actually start enforcing. Again, highlighting the notion here at Network to Code, we understand the real world. This is not an academic, conference talk kind of thing. This is real world practical application. That is, you need to be able to deal with those one-off situations, and we give you the path to do that. So I think that's, again, highlighting that power of Nautobot, that it isn't an all or nothing. You have a way to take the journey.
Absolutely. And adding upon that, our networks are always going to be constantly evolving. So even if we take the approach that all of our data is good, everything was built greenfield, we've had enforcement from day one, that doesn't mean that the next latest and greatest network solution doesn't drop tomorrow. And that fundamentally changes our network architecture. Like I mentioned, when I started with networking, all I saw and all I heard was three-tier network design. That was still what was taught by Cisco. ACI wasn't a huge thing just yet. We were still deploying Nexus 7Ks, 5Ks, and then 2K FEXs on the 5Ks as our three-tier design. And we can see very quickly how everything has evolved and changed in the time the very minuscule amount of time that I've been in networking. And that it's always just going to be constantly evolving, especially as we are going into a digital world, and how so many companies are going through a digital revolution where they are trying to better improve their capabilities to be able to respond to customers, respond to whatever business related item it is through a digital paradigm. And so that's always going to be increasing the workload and increasing the demand on the network and how we build, manage, and ensure reliability of our networks.
We do have a couple minutes left, and to be fair, as even admitted in the question, it is out of scope for this webinar, but I don't know if you know the answer here, Jeremy, but are there any upcoming features to handle field permissions?
I'm not sure off the top of my head from Nautobot core if there's the ability to enforce a user-based permission based off of a field and on an object. However, let me think about this. I would have to double check in the audit rule set if we have the request object, and if we have the request object that has the user, we should be able to do our own custom Pythonic logic around enforcing based off of a user's permissions that are assigned. I can look that up if it takes me just 2 seconds.
No worries. So just a quick comment there for, and I apologize, I don't know how to pronounce your first name, to the individual who asked this question. This is something absolutely that we could get an answer back to you. We do have your contact info here as you join the webinar. And or if you would like, if you are a member of our public Slack channel, this would be a great question to drop there. One of the members of our Nautobot core team or one of our architects will be able to get an answer to you back on that. And sometimes, we love hearing this kind of input as far as feature requests and things that maybe you're looking for. So, we're always open to that input. If we think it's great, we absolutely want to get it into the backlog to get it added to the core project. And we are right up at time. So I think, Jeremy, unless you have any quick comments, we can bring the webinar to a close.
I think that's all from me.
Excellent. thanks so much. It was an amazing, actually really cool webinar here today. So hopefully everyone enjoyed it here in the audience. Thanks, Jeremy. And thanks for everyone here today. And of course, this will be recorded and published here shortly on YouTube. Thanks, everyone.
Awesome. Thank you, Tim. Thank you, everyone.